Hello and welcome to video section 2.1 day 2. Remember, that's how I kind of label these. Our I can statement today is you can determine left hand and right hand limits once we get done with this. Also, the general limits. I've put a little note up here at the top, first of all, and you should read this section in your book. It's very short, and we're going to do some problems. We're going to look at graphs, find the limits, and then we're going to look at some problems where you have to draw your own piecewise function graphs, which you should be able to do, and determine the left-hand limits and right-hand limits and whatever else they ask. Remember that limits are always y values. It's wherever the value is on the y-axis of the point, okay, or the area. So always remember that. Sometimes students forget y values. That's what this equals, a y value, okay? Sometimes we write that as f of c because we're plugging in a c. So just keep that in mind. This is a left-hand limit. Another thing that I want to mention to you that I might do that some other teachers might not in your future is I call these left-hand limits LHL. That's easy for me to say, and RHL. Because sometimes I don't want to write all those letters. Okay, so left-hand limit, right-hand limit. This is how your notation is written. Pay close attention. This one has a negative sign. It's coming from the left. Okay, it's where is our function going to as it comes from the left. And this one, it's a C plus, x is going to C plus, indicates right-hand limit. And that is from the right. Okay, for once, math makes sense. Math always makes sense. Okay, so let's look at a real problem. Here is a piecewise function that's already been drawn for you. You could also draw this function from, you could write this function when x is from 0 to 1, you have a line. When x is from 1 to 3, you have another line. It's a y equals 1. You have a point at x equals 3, y equals 2. And at x equals 3 to 4, you have a line with, up to over 1. That is a slope of 3. So I'm not sure what the equation is, but you could write it because it has some kind of intercept down here. Okay, all those lines have equations up there in that piecewise function. All right, so what we're going to do first is figure out where all of these limits are going. Okay, so let me adjust this. First of all, we're looking at x from the right-hand side. That means, we're looking at x equals 0 from the right-hand side. So when I come to 0 from the right-hand side, my y equals 1. Everyone see that? As this comes from the right-hand side, y equals 1. As x goes to 1 from the left-hand side, this function is headed up to 2. All right? So the 2 is the y value when x equals 1. The function from the left-hand side is going to 2. The function from the right-hand side, on the other hand, is the y equals 1 line. So that function is coming this way, going to 1. All right, that's right-hand limit. This is a left-hand limit. All right, over here, 3. From the left-hand side, the function is going toward x equals 1. From the right-hand side, it's also going to x equals 1. Y equals 1. These are y values. My brain knows, but my mouth is saying something different. Okay, the limit as you go to 4 from the negative side is all the way up here at y equals 3. Okay, those are your left and right hand limits. Now, another little, a theorem that we have is when you see a limit without a plus or minus, like the one written up here, this means that your left-hand limit equals your right-hand limit, and that is the limit of note. Okay, that is the same as the general limit. Okay, and in your book, we call that just plain limit. If we don't say right hand or left hand in front of the word limit, that means your left hand limit equals your right hand limit at that point. Okay, at point C. Whatever that number is. Okay, let's look at some examples of this, and you might want to read on page 64 about this. Same graph, right? Does the limit as x goes to 1 exist? Now remember, from the left-hand side, y was equal to 2. From the right-hand side, y was equal to 1. Does the left-hand limit equal the right-hand limit? And let me write that. Left-hand limit is 2, right-hand limit is 1. So therefore, the limit does not exist. No. At x equals 2, does the limit exist? Well, the left-hand limit equals 2, or I'm sorry, 1, because y equals 1. And the right-hand limit also equals 1. Therefore, the answer is yes, it's equal to 1. At x equals 3, and this is probably the trickiest one, okay? As x goes to 3, remember, if you look on the page before, we said, well, 2 pages before, we said the left-hand limit of 3 was equal to 1, and the right-hand limit of 3 was equal to 1. Therefore, does that limit exist? Yes, and the limit equals 1. All right, and then it asks to find what is the value of the function at 3. Even though the limit at 3 is 1, the value of the function is this point up here, y equals 2. So the value of the function at 3 is y equals 2. All right, that'll come in to play when we look at continuity. All right, that's all of our work for today. Short and sweet video. Enjoy.